algorithm and framework in ransomware detection. Ransomware detection functions through the identification of anomalous activities, triggering the automatic alert for users. Once alerted, users can promptly halt the virus propagation, preventing the encryption of valuable or the sensitive files. Ransomware, a malware variant, seizes the control of data or the systems until a specified ransom is paid. The menace present in two forms: local ransomware, which immobilize the victim computers, and the crypto ransomware, now prevalent, encrypting personal files for inaccessibility. Existing framework leverage the static and the dynamic analysis alongside of the machine learning algorithm to aid the ransomware detection. And given this ransomware operational nature, a high accuracy level is anticipated. Detecting and countering the ransomware remains intricate due to its concealed presence within the application layer, payloads, and the encryption utilization against the application. Innovative strategies and the technologies plays a crucial role in fortifying the ransomware defense, preserving the data integrity, and the cyber threat. This study delves into the realm of ransomware detection, shedding light on the array of machine learning algorithms and the frameworks employed in this pursuit. The primary goal is to meticulously analyze and contrast the diverse frameworks and algorithms utilized for the identification of ransomware, encompassing the distinct challenges encountered by each framework. By conducting this analysis, the study offers a comprehensive comparative assessment which stands as a valuable reference point for forthcoming in the realm of ransomware detection. Bridging an existing research gap, the investigation rigorously reviews and aids cutting-edge framework that plays a pivotal role in the landscape of ransomware detection. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. This phase involves importing the necessary Python libraries and the modules required for data manipulation, analysis, visualization, and the machine learning tasks. And the second one is exploring the dataset. At this stage, the dataset is examined to gain a comprehensive understanding of its structure, variables, and the characteristics initial into the data. And the next step is data pre-processing. Here, it involves the task of handling the missing value data normalization, encoding the categorical variables, and the data transformation to prepare the dataset for the training. And the next step is visualization using Seaborn and Matplotlib. Data visualization technique using the libraries like Seaborn and Matplotlib are applied to create the meaningful plot, graph, and visual representation of the data set, aiding in the data analysis and the feature understanding. And the next step is label processing. This step involves pre-processing the label at the target variables, ensuring they are in a suitable format for training the machine learning model. And the next step is feature selection algorithm. Various feature selection techniques are employed to identify and retain the most relevant and the impactful feature that contribute to the model performance, improving the efficiency and reducing the noise. And the next step is splitting the data into the training and the testing set. The data set is partitioned into the training and the testing subset. The training set is used to teach the machine learning model, while the testing set evaluates the performance. And the next step is building the model. Here various models are built. The first one is SVC. That is, support vector mission is a supervised learning algorithm that aims to classify the data into the different classes by finding the optimal hyperplane that best separates the data points of the different classes. In this context of ransomware detection, SVC learns the pattern from the labeled data and creates a decision boundary to distinguish between the normal and the ransomware instance. The next one is decision tree. Decision tree is a hierarchical model that partitions the data based on a specific attribute to make the categorical prediction. In ransomware detection, a decision tree can learn the rules from the historical data to differentiate between the normal activities and the ransomware behavior by following a tree-like structure of false conditions. And the next one is of MLP. It stands for multi-layer perceptron. It's a type of artificial neural network characterized by multiple layers of the interconnected nodes. In the ransomware detection, an MLP can learn the complex pattern and the relationship in the data, making it capable of capturing the intricate ransomware behavior. And the next one is voting classifier. Voting classifier combines the prediction of multiple base classifier to make the final decision. In the context of ransomware detection, a voting classifier could integrate the output of the different models as of SVC, decision tree, random forest to enhance the overall detection accuracy. And the next one is LSTM. Stands for long short-term memory. Is a type of recurrent neural network designed to handle the sequence of the time series data. In the ransomware detection, LSTM can capture the temporal pattern in the data, which is crucial for identifying the sequential ransomware activities. And the next one is MLSTM, a modified version of LSTM tailored to address the specific challenge in the project, which include optimizing memory usage, improving the training efficiency, enhancing the model ability to capture the relevant feature for the ransomware detection. And the next one is DNN. DNN stands for Deep Neural Network, and artificial neural network with multiple neural layers, allowing it to learn the complex hierarchical representation of the data. And the ransomware detection, a DNN can uncover the intricate pattern and the relationship within the input data, leading to the accurate identification of ransomware-related behavior. And the next step is user gives the input. The beloved development model is integrated with the Flask web application, allowing the user to input the data for the ransomware detection. And the next step is the given input is pre-processed for prediction. The user input data is pre-processed to ensure the compatibility with the trained model, including the data normalization and the encoding. And the next step is trained model is used for the prediction. The pre-processed user data is fed into the trained machine learning model to predict whether it represents the ransomware activity. And the last one is final outcome is displayed. The prediction outcome, whether indicating the ransomware detection, is displayed to the user through the Flask web interface, providing the actionable insight into the potential threat. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The static folder containing of the folders like Octosys, JavaScript, CSS, and upload images files within it. And the template folder containing of the typical HTML documents. It include of home, index, sign-in, result, and sign-up pages within it. And the APIs and py file, which likely contain the information related to the front-end logic. It includes the code written in Python that handle the server-side operations, such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a CAV file which contains the information of the algorithm and loaded into the project code during the runtime to utilize the training model for the various tasks, such as making the prediction on the new data or performing a specific operation. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual step, making it a popular choice for the data science. And the sign-up is a DB file which contains the information of the user and store it. And here for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command cd space and paste this code folder path. By this it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or the logical issues within it. And then click on the enter button. After running this app.py file, the Flask framework will load the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice and prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we redirected to this page containing of some details and the title of this project, and then click on the sign up button. Here it will redirect to the registration page containing of some necessary details that are needed to prepare to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of username and password that we need to fill, and then click on the sign login button. Here it will redirect it to the login page containing of some details that are need to be filled to detect it. And I'm entering those details as of entry as 100004, and the duration is -1, and the original bytes is of -1, and the rest bytes is of -1, and the missed bytes is of 0, and the original packets is of 2, and the original IP bytes is of 80, and the response packets is of 0, and the response IP bytes is of 0, and the proto ICMP is of 0, and the proto TCP is of 0, and the proto UDP is of 1, and the con state others is of 0, and the 0, and RSTO is of 0, and for RSTO-S4 is of 0, and the RSTR is of 0, and the RSTRH is of 0, and the con state is of 1, S1 is of 0, S2 is of 0, and S3 is of 0, and the S4 is of 0, and SF is of 0, and SH is of 0, and SHR is of 0, and then click on the predict button. Here it predicted as of the ransomware trace is of 0 based on the IoT data value. In this way, we can recognize the ransomware detection by using this machine learning algorithms. And by clicking on the home button, here we can re-enter the other details too. I'm entering the other details as of entry with 109830, and the duration is of -1, and the original bytes is of -1, and the rest bytes is of 0, and the missed bytes is of 2, and the original bytes is of 80, and the original IP bytes is of 0, and the response packet is of 0, and the response IP bytes is of 0, and the protocol ICMP is of 0, and the protocol TCP is of 0, and the protocol UDP is of 1, and the constate OTH is of 0, and the constate REJ is of 0, and RSTO is of 0, and RSTO-S4 is of 0, and RSTR is of 0, and RSTRH is of 0. And constate S0 is of 0, S1 is of 0, S2 is of 0, S3 is of 1, S5, SF is of 0, SH is of 0, SHR is of 0. And then click on the predict button. Here it predicted as the ransomware trace is DDoS based on the IoT data value. And in conclusion, We provide a comprehensive survey of ransomware types, common frameworks that are used to detect the ransomware, and the machine learning algorithms in which we used. A detailed list of all pertinent information is gathered and arranged in a table. Through this research project, we have predicted the ransomware detection of the various types within it.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.